Let's take a look at the three formulas that we'll be using to describe interest. So the first one is our simple interest formula. That's just where we add our interest rate to 1. The second one we learned last week is compound interest, where n changes depending on the number of times you're compounding. For instance, if you are compounding monthly, your n will be 12. If you're compounding quarterly, your n will be 4. Today we're looking at a new formula for continuously compounding interest. The key to this continuously compounding formula is this number E right here. So let's deep dive into what that E means. E is not a variable. E is a number. E stands for 2.72. Just like how pi is a symbol that represents 3.14, E is a symbol that represents this mathematical constant of 2.72. So when we're using the continuously compounding interest formula, our multiplier is represented by E, or 2.72. P is still our principal or our initial value. R is still our interest rate written as a decimal. And T is still time. So this formula is pretty easy to use. Let's say we have a problem where you deposit $5,000 into an account with an interest rate of 4.5%, compounding continuously. It's this key word right here that tells me I'm going to use this formula. So we can easily write our equation for it, where it's y equals my initial value, my principal, times E raised to the 0.045 power times T. And that's it. If we're asked to determine the value in the account after, say, 5 years or 11 years, we would simply plug that number in for T.